Hello, everyone. Welcome to Innovations in Digital Design webinar. Innovations in Digital Design is an online platform for sharing innovative research ideas and design works in the digital design field. We aim to explore the nature and future of design by showcasing the outstanding work of young designers and scholars from all over the world. IDD operates once per month, offering oral presentation, discussions, and online courses in English. Our recordings are uploaded to YouTube and Bilibili, available for free to all. And this is our second webinar, and today we invited two innovative researchers and designers, Wei Wu and Yuqian Sun, to introduce their latest projects on AI-driven innovations in interactive design. Wei Wu is graduated from the Master of Design Studies of Harvard GSD, and the topic she will be presenting today is a text-to-3D generative furniture design tool based on augmented reality. And Yuqian Sun is a PhD candidate of Royal College of Art in London, and she works on AI researches and chatbots. And her topic today is hybrid agents, fusing AI characters with everyday life and social interactions. So first, Wei.
Hi everyone. So now can I share the screen?
Sorry, wait a minute. Hi, Yufan. Could you please? Oh, okay.
Oh,
Notice the YouTube. It should be known that the YouTube. Please wait a minute. Sorry.
okay.
Okay, that's fine. We can start.
All right. Hello everyone. Today I'm going to talk about a text-to-3D generative furniture design tool based on augmented reality. I'm Wei. I'm from Harvard University Graduate School of Design, and I left my email on the right. Here's my abstract. So recent research has demonstrated that generating high-quality 3D models based on textual descriptions, which is text-to-3D, has the potential to be used in actual design application to improve work efficiency. However, the existing design tools are limited for inexperienced users as they require stronger spatial awareness skills to concretize 3D designs. So in my study, we propose a digital design tool that utilizing augmented reality to visualize and edit text-to-3D generated design. And here is my workflow. So firstly, we generated, the main task is generating task to 3D models. But then we can add on some new features like audio to text. And we can add this kind of 3D models into WebAR. And how do we generate audio to text? We use Whisper. Whisper is an automatic speech recognition tool trained by OpenAI. So it enables not only that we change from audio to text, but we also can translate multiple language into English that can be utilized for generating text to 2D image or 3D models. And then for the text to 3D, we have multiple ways to do that. First, I'll introduce text to 2D image and then to 3D mesh. This is generated by Stable Diffusion and Stable Dream Fusion. And secondly, Point E by OpenAI is a new tool that can generate it from text to 3D point cloud. And then we can use 3D point clouds to link together and make 3D meshes. So firstly, we go into stable dream fusion. This is how we use text to generate it to the image and then to 3D mesh. For the stable diffusion, the 3D environment representation is nerves. Nerves is representing scenes as neutral radiance fields for view synthesis. And a nerve produces volumetric data. And how we read the data is that we use PYM cubes, read the volumetric data and transform into triangles, which is mesh. The processing time is super long for stable dream fusion, and because it is generated through nerves. Why it is that long? It usually takes like 3 to 5 hours. That is because nerves needs multiple stable diffusion images, generated images, to achieve a volumetric model. You can see the image on the right. It's like every angles you should generate a photo. And that kind of image is generated by stable diffusion. So usually stable diffusion, it takes like 20 seconds to 30 seconds to generate one image, but then you have so many angles. So you have like a really large image database to make. So then for stable dream fusion, usually when you generate a model, it takes about 3 to 5 hours GPU hours. And for this kind of stable dream fusion model, obviously it has some advantages. The nerves are coherent and high quality models. It can create high quality normal surfaces, geometries, and depth. And it can generate clean mesh with detailed textures. But obviously for the drawbacks, it required multiple GPU hours to produce a single sample, usually more than 3 hours. This kind of chair that I make, I use the prompt as a black leather chair with 4 wooden legs, and it generates perfectly. But it takes me like 2.5 hours to make. And this one is the official example of stable dream fusion. But this one is like, it is the one that appear on the paper. So they use text to the image with Imagen. Imagen is a kind of tool that has not been released yet. So we're not going to know how they do it, but we use stable diffusion to imitate the Imagen part. And then we use dream fusion to complete the 2D image to 3D mesh. You can see for the original paper, it has like really high quality, but now we are not able to achieve. The second way is Point E. Point E is an OpenAI embedded tool that we can generate from text to 3D point clouds, and then connect it to 3D mesh. For Point E, the method is that first generated a text-to-image diffusion model, and then we produce a 3D point cloud using a second diffusion model which conditions on the generated image. This is how we change the model. So firstly, we have text-to-generated image, just like Stable Diffusion or Midjourney. And then if the image matches, there is a large 3D models database of OpenAI, then we'll link the text to this kind of 3D models. And then with the inference is that all kind of text can align this kind of 3D models. And the 3D environment representation for Point E models is 3D point cloud. And we use marching cubes to read the 3D point clouds and transform into mesh. For the black chair that we see, I put the prompt is that a black bar stool. And the process time is only like 50 seconds for text to 3D point clouds. And then I use 50 seconds to generate a low quality mesh. And you can even use like 60 seconds, which is 1 minute, to generate a high quality mesh. So in total, it only takes 30 seconds to 90 seconds to generate it from point E method. The pros is very obvious. It's very direct, generated point clouds from text description within a while. It only takes 30 seconds to do it, and it can be accelerated. And the drawbacks is that it only works for simple prompts with, in my text, 1 or 2 colors or 1 or 2 adjectives, like a black chair, a black spar tool, that is. And the second way for point it to do it is the same. So text first generated to 2D image with stable diffusion or mid-journey, and then use 2D image to generate it 3D point clouds with point E. And then we use 3D point clouds to download into 3D mesh. For this method, we can generate it very clean point clouds, which captures fine details such as surface texture and small features. Compared to other methods, point E is relatively fast, with generation time typically taking less than 3 minutes. But the drawback is, for point clouds, they need to be denser to generate a more accurate model. The current transform method used by point E may not work well for all types of point clouds, leading to issues such as incomplete meshes or broken geometries. This kind of models on the right is that I used the prompt, a black leather chair with 4 wooden legs, and the process time is like 20 seconds from text to image in mid-journey or stable diffusion, and it took like 1.5 minutes to generate it from image to 3D point clouds. And download to mesh, transform to mesh, it takes 50 seconds to download a low quality mesh and 60 seconds to download a high quality mesh. So compare the 3 methods. When I generate the same prompt, a black leather chair with 4 wooden legs, the stable diffusion and stable dream fusion method, which is text to 2D image to 3D mesh, takes so many hours. The process time is too long. It's like 3 to 5 GPU hours, but the model quality is the highest. And for point E, it's like really different. It only takes 30 seconds to 17 seconds to complete the overall model, but the quality is quite low. So we can choose from whatever we want to input in augmented reality. And usually for design tool, we like it to be displayed in real time. So then I choose the second method, the point E, text to 3D point clouds to 3D mesh, to continue my study. So from 3D mesh, how can we input 3D mesh and display it in WebAR? Firstly, we should generate all the 3D meshes into GLTF format. GLTF is an open format specification for efficient delivery and loading of 3D content, especially used in websites. And usually, a GLTF access may deliver 1 or more scenes, including meshes, materials, textures, skins, skeletons, and animations, and even lightings, and camera sets. So that is a really convenient and small format for us to save all the informations in the scene. And then we can display it in WebAR, which is in Chrome, and the platform I choose is 8ball. 8ball is right now the world's leading WebAR development platform, and it's really convenient. And I called my furniture design application, I call it Furniture. So furniture and comes true. It's an AR application that enables users to generate furniture and home decor products according to audio descriptions, which are displayed in AR. This application allows users to visualize the design in real-world settings and make adjustments as needed. before making a purchase. This allowed for a more immersive and convenient shopping experience for those looking to decorate their homes. And this is right now what we said when point E generated from photos. It reveals bad quality photos. This is where I put my prompt as a blue Diane sofa, and the process time is like about less than 2 minutes, but the shape is like all broken. So then I choose this method that is the simple methods from text directly to 3D point clouds and then download it as 3D mesh. I insert the prompt as an orange sofa, and the process time is about 45 seconds, and I can almost take it, and the technology will continue to evolve. So maybe in the future, we only need like 10 seconds to 30 seconds to do it. This is how I do the experiment. So firstly, I have a space, and I look around the space, and I was thinking of what kind of furniture that I like. And then I shout out my words. Sorry, the audio might have some problems. So I shout out my words, and the whisper of OpenAI can recognize the words I say, and then it will generate it it will translate it into text. So what I say is that a black chair with 4 legs. Then I click generate it. The generated takes so long, so I just leave it in a while. And after that, this is what we see is generated from the point E, so it's a little bit low quality. And I can scale it up. I can move it anywhere, put it wherever I want. That's my neighbor, and he just passed by. I can adjust where I like to position, and here I find the right spot. And now I have it. I can continue to generate another furniture that I like. And this one is the high quality version of the same prompt. It's also a black chair with 4 wooden legs, but it's a high quality version that generated for about 2 to 3 minutes. And this one is obviously like the point cloud is denser and the texture is smoother. All right, just an example of what I'm going to show. And here are my references. There are like Dream Fusion is a text-to-3D using 2D diffusion. And Magic 3D is like another high-resolution text-to-3D content creation. And thank you. Here is the time to Yufan. Oh, sorry. It's not sure.
Thanks for sharing. It's a very nice presentation. So now it's question time. Does anyone have any questions for Wei?
Hello, can you hear me?
Yes.
Hello?
Yes.
Yes. I have a small question about the technical details. Like I'm not very familiar with the Mid Journey or other AI generator for image. So I want to know how you can generate different angles of the furniture with similar, similar visual outlines.
Actually, let me share the screen again. And I didn't generate it different kind of angles. I only generated once. Wait, let me share the screen. Wait, oh, wait a minute. Wait a minute. So I didn't, I only generated one, but I think why you see different angles is that when you're using point E, it will like automatically generate it 4 to 9 grid that let you see. It is just the UI of the whole model. So unlike other models, like when you generate it in Stable Dream Fusion, you can rotate it just like in Rhino or Blender. But then when you use point E, you cannot rotate the model, and but otherwise it show you 9 views or 4 views of the model. So it's like different angles of the model itself, but it's not the images that I generated from Midjourney.
Okay. Thanks for the answer. So it means like point E can automatically get different angle of the image, but how can it get the correct? I mean the back of the furniture. It's based on some machine learning technology or other technology.
Right. It cannot get it back. So almost all kinds of the back photos are like broken. Or the sofa I generated, like 8 of 10 of them are like fully broken on the back. But I found out that chairs are like for chairs it's like much better. I think it is because the chair database is larger than sofas, but I think that will increase later.
So can I use this technology to generate other things, like generate food or buildings, or it can only use for furniture?
Why I choose from furniture is that for furniture, you cannot imagine for a very complicated scene. And right now, what point E can do, it can only generate 1 to 2 colors or 1 to 2 adjectives. So furniture is a simple design, rather simple design than some others features. So you can only say furniture colors or textures or materials, but like no more. So that's why I choose furniture design as my first step. And if the AI can, it can accelerate like better in the future, then we can push into architectural design or more. And a fun fact is that on the Point E website and also on Stable Dream Fusion website, the best quality model is the corgi dog. And because most people are generating cats and dogs in their family, and that is the first thing that they can think of. So the dogs database are a lot like high quality than others.
Okay, thanks for the answer. Maybe I asked so many questions.
It's a good question. Thank you.
Thanks.
So does anyone else have any question?
Hello. Okay, thank you for your amazing presentation. And I have 2 questions. The first question is, does your model always stand on the ground? That means your application recognize the ground, the wall, the environment?
The models are when it generated, it first go into the 0 point on the X plane, so usually it's on the ground. But then the scale is always changing, so that's why we need to put in AR and we can scale it with our fingers. So that's why I start to link it to AR, but it will always stick to the ground. And for what is best in AR is that you can actually visualize the ground, and the camera can recognize where is the ground. So the models are always put on the ground, and that is where it's best for furniture design, actually.
Okay. So, how can you make sure the size or the scale of your model is just according to your feeling or a subjective experience?
Yeah, right now it's like fully based on subjective experience, but what I designed this kind of tool is like I like to know what people need for the size. So people can scale the furniture to the exact size that they want. They really fits the environment. And then they will, based on the size, they can choose from like whatever furniture they like.
Okay, thank you. That's all my question. Thank you for your answer.
Thank you.
Okay, Conan.
Hi. Thanks for your comprehensive presentation of your research. It combines so many technologies. So I think that the whole workflow is quite continuous. So I even believe that the whole flow can further develop into commercial applications. So perhaps you can try to initiate your own business. It perhaps may kill a lot of furniture designers. So just a quick question is, what do you think the current limitation of transferring your research to practical applications? So perhaps you can say it may take a lot of times for the calculations. It may take a lot of computation resources. So perhaps the customers have to wait half an hours for a result. So I don't know.
Yeah, right now the worst situation is definitely the calculating time. For the stable Dream Fusion model, it really takes a large GPU's resource. And right now I'm using my lab's like most expensive GPU. It costs like $6,500, and then it still needs like 2.5 hours to generate a chair model. So I think point E in this case is really convenience and more realistic, and perhaps we leave them a gap. We leave them like a space for them to grow. But right now I create this kind of workflow, and for people then can always do such kind of experiments, and they can build their applications, and we wait for AI to grow for another 3 to 6 months perhaps, and they could be much better.
Yeah. Thank you.
Okay, thanks for these questions. And now I think that's if nobody has any questions, so